Okay, so this is my project. I'm just going to take you through the components quickly. So this is my power supply for the unit. It outputs about 5 volts from these two outputs here at about 2 amp hour. And this is the smartphone that we'll be using to control the system. And these are the electromagnets. So before we go into the other components, let me just say so this is a transformer remote remote isolation device. And what this means is it's basically a unit that will be used to isolate pad mounted transformers remotely. So instead of having a technician or an operator go into the pad mounted transformer, into the compartment, and open the load break switch manually using a link stick, we are going to use this system here. So the brains of the system is a arduino nano and HM10 Bluetooth module, and that right there, this is just a switch for the magnets. So the magnets need to be switched on and off at different times, so that's why I put a switch there. And this is a 12 volt 1.6 amp motor, and these are just 12 volt 0.63 or 630 milliamp electromagnets. And so this is just my connection. So what will happen, or what the way the system works briefly, is I use the smartphone to send signals to the Arduino Nano via the Bluetooth module, and then the code in the Arduino basically tells the motor whether to rotate clockwise or counterclockwise, depending on whether you are opening the switch or if you're closing it. And I use that that relay module for switching, because these are obviously 12 volt components, and Arduino works with up to 5 volts. So yeah, so that's in a nutshell what the system is and what it does. So let's see. So this is what I have done on Blink. I called it test for now. So what I would normally do, let me just it's still connected. So what I will do initially is well, once the system is on as it is now, I'll come here and then I will say connect to BLE device, and that CC41-A is my HM10. So say okay to connect to that. Okay, and once it's connected, you can say okay and go back here and then run the app. So this is the button I will be using for opening, and that is for closing the switch. So yeah, so let's test this. Open. So it will turn for 5 seconds and then stop like that, because it takes about 5 seconds for the load break switch to go to a completely open position. And the same will happen with the closing. So if I close it, it turns in the opposite direction now, and it will wait 5 seconds and then close. So that's how the motor part of it works. And the magnets, the compartment of the pad mounted transformer is made out of steel. So we needed something that can help the system to stick onto the load break switch, because there's no supports there. So I'll be using these electromagnets as the sort of support for the system to hold it in place while it does the operation on the load break switch. So at the moment, as you can see, the magnets are not operational, they are not energized. So once you have put, or you've placed the system properly in place, the switch will be close to your hands somewhere. So you just switch it on there, and now your magnets are energized. There we go. That one's energized, and that one's energized. So yeah, that's essentially how the system works. Let's see if I can, yeah, there. So both magnets are energized at the moment. Okay, So that's basically how the entire system works, and it's at the moment on breadboard. As you can see, I'll just at some point transfer it onto Veryboard and make it look much neater than what it does now. Thank you.